Thank you everyone for being here today. I'm going to make a couple introductions. My name is Edward Quintero. I'm a co-founder of Mol3D, and with us today is Robert Vignon, who is also a co-founder, and then Kirill Chepizhko, who's the instructor for the Master Hard Surface Modeling. Kirill's going to actually be doing a demo today, and he's going to be talking about his experiences in the industry and how he uses hard surface modeling, or as some people refer to it, CAD modeling. There's a couple of differences there, which Kirill will cover, but uh, basically it's creating 3D models for anything that's not an organic character. So anything that's not like a human or a dog or a cat, that kind of thing. If you're trying to go for like architecture or sci-fi vehicles or robots, that kind of thing, that's what we in the entertainment industry refer to as hard surface modeling. So before we get started, I just wanted to talk a little bit about who we are, Mol3D, and just give a little bit background about what we've done and what we're doing with this class. Mol3D is a website that me and Rob created about a couple years ago. Primarily, we started the website as a resource for people that were interested in creating products. So people that were interested in specifically 3D printing to create prototypes or their own products. We were at DreamWorks at the time, and the Form 1 3D printer came out as a Kickstarter, and Robert was one of the first people that I knew that had a 3D printer that purchased it. And so at that time, there wasn't any resource out there for people like Robert and I that were actually 3D artists. And we felt like this was an amazing technology, a great opportunity for us to be able to have access to a tool that could enable us to create anything that we wanted, basically. And so we started the website with just mostly talking about how artists could use 3D printing. And throughout the past couple of years, we've had gallery shows. We've done a lot of local workshops here in Los Angeles, where we've taught software like ZBrush and 3D printing to a lot of students that have come in from local or even outside of the country. Um, However, the workshops were great, but a lot of people couldn't make them because they were here in Los Angeles. So since then, we started Mol3D Academy, which is kind of the online version of what we are doing with the workshops. So this is an opportunity for people that don't live in Los Angeles to learn from professional instructors and teaching things that you usually don't find that often online. Stuff like 3D printing, and in this case, hard surface modeling, which is what we're going to be talking about today. So we'll talk a little bit more about the academy and how the classes work towards the end, but I just wanted to make a brief introduction about what Mol3D is and what we've done. So now let's get to it. So I wanted to introduce you guys to Kirill Chepizhko, who is not only a Autodesk Fusion 360 master, but he's an awesome artist, a great 3D modeler, and all-around great guy. So thanks, Kirill, for being here. I'm going to go ahead and pass the mic to you.
There you go. You should be able to see it now.
Yeah, got it.
All right. So thank you for having me. I'm very flattered. I am a digital artist coming from the motherland, Mother Russia, and I have moved here in the United States in California about 9 years ago. But I've only been a concept artist and working in 3D for only the past 5 years, and specifically in hard surface area for the past 2 to 2.5 years. So it was kind of a long journey, but I wanted to briefly talk about my experience and how I started using 3D, because initially I was a 2D artist and I was only using Photoshop. And then one day a friend of mine recommended me ZBrush, and I started playing around with it, and I didn't like it right away. So it took me about like 3 or 4 tries to begin working in ZBrush, but nonetheless it was the most smooth experience coming from Photoshop to ZBrush, because I didn't know any other 3D, and I didn't have that the preconception of modeling in polygons. So ZBrush, became natural to me, and all the things that people from usual 3D background don't like about ZBrush, I instantly liked. And then I spent a couple of years working in ZBrush, and I had a great opportunity to join the ZBrush Summit 2 times in a row, and I was in the hard surface sculpt off because of that. Because I was at that point I already had a couple of tutorials in ZBrush. I started doing my professional work in ZBrush, and then I started to look for ways to expand my portfolio and to make the work, to basically work less and get more results. And that's also when I sort of started to specialize in hard surface. I like to compare it to sort of like graduating from the university, where for 4 years I was just doing 2D and 3D, and then my major kicked in, and I decided that my major would be a hard surface. So for that particular purpose, I picked up Fusion 360, which at that time was just, I think I joined Fusion 360 almost right after beta. So I've been in the software for at least 2 years, I think now, like a year and a half. I might be wrong with the dates, but and the reason I joined it is because it allowed me to do a lot more than I could do in ZBrush, and it was a lot more accurate. It's my idea about this is hard surface belongs to the engineering world, so all the designs that you do are considered to be engineered designs and engineered by humans. So I think that using engineering tools for the engineered look is a proper way to go. So that's why I started to work in CAD. And I wanted to give you just a couple of examples of what you previously saw, maybe on the Mold3D Academy page, or while you were waiting for the webinar here. For example, this image of the jet engine was rendered in Keyshot, but it is done completely in Fusion 360, all in one scene. So you can see it right here. And it's a fairly complex object to make, but I'm not experiencing, at least as I'm looking at it on my screen, there is no lag in terms of rotating it or working with it. It's the scene does have its limitations, but even stuff like this is fairly easy to work with. And then I wanted also to show how far you can push Fusion 360. And maybe that's not even the furthest, but if some of you have seen this image of the rover that I did, it was, again, rendered in Keyshot, and I'll talk about it in a second. But this is the render, but the actual file here is in Fusion as well. And this one is an assembly. So it's just something that I will be talking in my class in the later in the later lectures. But assembly basically means that this was assembled in this the rover was assembled in this scene, but it's referenced in separate files that are stored separately in the program. So I'm working on a wheel, or I'm working on an assembly like this, and then all of these little parts are referenced inside the final scene, and they're put together. And the best part about it is when I update something in this little part in the it's called a component. So you can see how many components I have. I also have bodies that are just sitting here in the scene, but this is the amount of components I have here. And when I'm changing something inside of a component that is a separate file, it updates in the final assembly. It's really cool because you can achieve a lot more with this and have your files structured and organized, and at the same time make sure that it's not lagging.
Hey, Kirill?
Yeah.
A couple of questions for you, actually.
Sure.
What are the file sizes like with the separate components? And then is there a perspective camera inside of Fusion 360?
The file sizes are relatively small. I think they're definitely lighter than OBJ. But I think this rover would be in a native file. It would be something about 300-400 megabytes. But the cool part about it is the Fusion 360 is cloud-based, so everything is stored in the cloud. Very rarely, or there's like a short time frame that Fusion keeps it on your hard drive. So you don't have to worry about the storage. It's constantly being updated and sent to the cloud, and you can download it back and forth. But it does keep your files on the hard drive.
Okay,
And,
so it caches it locally. Okay.
Exactly, yeah.
Cool.
And as far as I heard from the support, the storage space is unlimited.
Okay, nice.
And the perspective, yeah, you can turn on the perspective in the cube settings. You can just turn on the perspective. There's only one camera for the perspective.
Oh yeah, I see it.
But it does
There you
exist.
go.
Although I prefer working in ortho.
Yeah, for sure.
Easier. One more thing I wanted to show, because you've seen the watch probably on the Mold Academy, Mold 3D Academy webpage. This watch rendered in Keyshot as well. And I have it here just to show you what it looks like inside of the program. You can see that you can adjust and assign different materials. You can adjust, assign colors. So you can also do rendering inside Fusion 360, but I feel like maybe it's not quite there, although I've seen really, really good renders from Fusion. But for me, it's a matter of, you know, how I started. So I started using Keyshot when I was using ZBrush. So, and I'm still using ZBrush. So I'm kind of used to Keyshot. So the huge benefit of modeling in CAD and rendering in Keyshot is that it's not polygons. So it's basically unlimited zoom in, very smooth lines, no tessellation. So if you're only an illustrator or basically like a concept artist like me, when you don't have to worry about polygons and stuff and about how the geometry looks and what the mesh looks like, in this case, you get amazing results from Keyshot.
Hey, Kirill, so there's obviously a benefit to the unlimited tessellation. In terms of modeling speed, when you're comparing maybe a package like Maya for hard surface modeling, or even Max, or even something like Rhino, which also has, I think, similar tool sets, would you consider Fusion be a fast poly modeler software?
I think it's a trick question, because I know a lot of people who are really fast in other modeling softwares. Like I know people who are really fast in Maya and Max. But I think certain designs and certain problems need very specific solutions. And in this case, Fusion gives you every tool to be able to solve pretty much every problem. And when I say problem, I mean like shape in the design.
Yeah.
So it's just I was just talking to my brother today about it, and I was comparing it like eating soup with a hammer or eating soup with a spoon. You can eat the soup with a hammer and you'll finish it in 3 months, but you can finish this bowl of soup with a spoon in a day or less usually. Yeah. So that's pretty much the difference, because I really like the set of tools that Fusion gives you, and they're geared towards making that design look like it's been, well, I mean, you know, this software is not really for concept artists. It's more for concept designers, people who are modeling for the real world, for 3D printing, or for CNC milling. But I'm adapting this tool to my needs, and because it doesn't differ very much, the needs of the look of the concept design and the concept art in games or in movies, I'm using this as my primary tool. And I think you think it would be a good time to do the demo, just to give a taste, or?
Yeah, I think so. I have a couple cool questions here that kind of flow for the next thing. It's just more of a comparison. Have you ever used Moy 3D, and is it comparable to Fusion?
I've used Moy 3D. It's a smaller standalone program. It also works with splines and solid body modeling, so you can say it's CAD. But it's just the interface that I find more appealing to me. In terms of capabilities, I think Fusion, definitely has a lot more in terms of 3D printing and CNC milling and simulations such as thermal simulation and all kinds of simulations that are important for engineering. Moy 3D doesn't have that, so Moy 3D is just modeling. That's a drawback. And other than that, I know people from the industry who have done amazing stuff in Moy 3D, but you know, it's all about the person, the speed, the comfortability of working in it, the user interface, and your user experience. It really all depends on you. You know, it's just you who needs to adapt, I guess.
Awesome, great.
So I wanted to also show you real quick that this is a model of the lightsaber that I'm doing during the class, and I take it from scratch using the references that I could find over the internet, and I model the hilt first, the basic shapes and everything, and then in later lectures I explain how to slice it, how to start adding all the details inside, and in the class I talk about on how to make it. Well, this is all referenced, more or less. I would say it's referenced about 80%, so it's not exactly precise, but I talk about how to be able to come up with ideas like that and be able to create a believable design. And I wanted to show you the results of this. I don't go in detail over how to render it, but this is the render of the lightsaber. And you can see it's identical, like nothing has changed. The only thing is I added the crystal inside, just like on the reference, but I did that in ZBrush. Just a 30-second sculpt of a crystal. So I just want you to understand like why Fusion is better than polygon modeling specifically for concept art, is the look, the quality of the final picture that you can achieve, and the ease of it and the speed is it's much faster, and it's just really looks like really tight looking models. You know, to achieve something like that in 3D Max, you would have to spend a lot more time. So, you know, because of how it is in our game, you know, in our industry, everything, you know, every art director wants everything yesterday. So speed is very important. And in this case, it's also the looks. Which one more thing worth mentioning is that the ease of export and import. You can export in STL for 3D printing right away, or you can export in STL and send it to ZBrush. So this software, CAD has been around for quite a few years, so it's very easy to use with other software. I've seen models, and my friend and I taken models from Fusion 360 to 3D Max, no problem, and for retopology. And it's just a tool that is not being currently used very much in the pipelines in the entertainment industry, so not in movies or in games. Although right now I'm working for a company called Bosky. It's a company created by Cliff Blazinski, the guy who started Gears of War. And I am successfully using Fusion 360, not for the production pipeline because I'm a concept artist, but they take my models and I give them OBJs and sometimes STLs. They take my models and all they need to do is clean them up and retopo. So the point is, it's actually useful in production, and pretty soon I think it will be catching up. So just to give you an example of why Fusion is powerful, I will try and show you just the stuff that I like to do. I have prepped some time ago. I have prepped a couple of shapes. So these shapes are just all the like nurnies and nuts and bolts that are usually are time consuming and take time to model. And then especially if this is a cut. But what I like to show is how easy it is to perform all the Boolean operations. as I understand that Boolean operations are, those operations that everybody hates doing in other software. Because
those are the worst.
it's funny because in this one, they are actually the best. And
yeah.
So just to give you an example, I will take something that has already been prepped. And this goes obviously for any shape, any design. You can start doing the libraries, start collecting things, and saving your designs. Let's say you spend some time modeling a finger for a robotic arm or modeling a joint, and you really like it. So you save it, and later you can reuse that shape for your next design. But more than that, you can even reuse stuff like this. So a Boolean operation in Fusion 360 is called combine. You can see that I have the main shape here, and I have placed the shape that I will be cutting with. And you have to think about it as you would do it in real world, pretty much, let's say with clay and with piece of metal or whatever you want. You take that piece of metal and you stamp it into clay, and it will leave that stamp, in the reverse shape of the design. So this operation works real easy. Just target body, I say that this is the target body, and then the tool body, I say I wanted this to be the tool body, and I can choose between several operations: cut, join, and intersect. And in my case, I want to cut. If I wanted to join it, we'll just join it. But if I wanted to cut and maybe keep the tool, I kept the tool, and after the cut, you can see that it only took one click, but it created the inverse shape of my bolt. Plus, after I commit, I can keep adjusting it like this, and I can keep working on it and making it better.
So you can add bevels to any of those edges, or chamfers as they call them, I guess.
Yeah, it's in here. It's called chamfer and fillet. But you can absolutely change everything, so it's not just, it's not set.
Mm-hmm.
So, most of the time, all of the modeling trickles down to two Boolean operations: joining and cutting. But that's actually not exactly, but that's how it's done in real world. The CNC milling, so let's say 3D printing, if it's additive, right, it just adds on top. So you can think about it as it Boolean shapes together or something. And with CNC milling, it's the opposite, it's subtractive. So it just takes this brick of metal and will mill things right out of it. So for example, if I add the fillet here, you can see that it's all changing on the fly. It's not always as simple, of course, because right now this is not a complicated shape.
Yeah.
But with something where I have my rover, it wouldn't be that easy, because it's a pretty heavy model.
Mm-hmm.
But you can see, you can understand that now that you're looking at my saber, your mind automatically starts to wonder, like, how has this been done? Some of the parts were cut, some of the joints, some of them were chamfers, fillets, creating basic shapes. So there's pretty much how I work in Fusion is lots of Boolean operations, which is practically the opposite from what people do in the real world. With real tools. And so Booleans and sketches, but that's something more common, I think, with other software, where you sketch a lot. You sketch your shape, sketch your the desired profile, and then you pull it and keep adjusting. So the only trick here is to think about it as, it's called solid body modeling, and you should treat it that way. It's completely different from polys, but at the same time, that's the benefit, the fact that it's so different.
Awesome. I have a couple questions for you, actually, because these kind of fit in well. So I think I know the answer to this, but I'll let you answer it. So Unity, right? The engine, the game engine. Now this is you can output polygons out of Fusion, right? Like an OBJ file, correct? It's highly
Yeah.
tessellated, right?
Mm-hmm.
So if you wanted to use this program with a software like Unity, the basic workflow, I guess, if you will, would be export out your high-res model like you would at a ZBrush, and then you'd have to retopologize it, right?
Yeah,
To
that is
make it a
correct.
game ready.
And I have experience like that as well, where just the same way you treat ZBrush models, you treat them as a high poly, the source for baking, pretty much. You can treat this as your high poly mesh, and then you retopologize. You don't really retopologize this mesh. You create a low poly version of it.
Yeah.
Retopologizing, and then you bake all the details onto it.
So you can bake the details right off of this onto any low-res cage, really.
Yeah, I don't see why not, because at the end, when you export the model, all it is OBJ that is all triangulated, or decimated, as you call it in ZBrush.
Yeah.
Just like you would, if I took this model into ZBrush right now using STL, and then I saved an OBJ out of it and showed it to you, you would not be able to tell the difference whether it was done in ZBrush or Fusion. You can only tell the difference if you used to work in Fusion and you know certain ways the geometry comes together, and you know, oh, that's way too clean for a decimation. Like it doesn't happen in the real world. And then you start thinking, okay, this is probably Fusion.
I see. So another question I have from the Q&A box is so we kind of already answered this. How much cleanup needs to be done when importing Fusion to polygons to base program like Maya for rendering? So if we wanted to bring this model into Maya just to render it, it's not going to have any UVs, right?
It's not. I've tried doing this with Max. All you have to, the best way is just to export as a CAD file, because Max understands CAD files.
Okay.
And then do the conversion inside Max. That way, you will be able to have more control over how it converts.
I see.
And then you can just do automatic UVs, and that actually works just fine. I have examples, and actually, I'll pull that up real quick. I have an example of a file. It was my test doing the model in Fusion, and then this render is done with Corona renderer. So this is a screenshot from Max. No UVs, so just like automatic UVs, the box UVs. And you can see that all the geometry is coming out nicely. This whole thing used to be CAD file, and then I converted it to editable poly, and you know, dropped some materials and rendered it. So no problem whatsoever. I have too many examples of other friends working in between Fusion and Max, and they have zero problems with it. I actually like to work in between Fusion and ZBrush. There's a certain way that I have described previously in some tutorials, and I think I will be touching on it in class, at least in the Q&A. We can talk about it, how you can use all those Fusion parts to create a kit bash set for ZBrush, like an IMM brush. So for example, all those nuts and bolts that I have here, I can easily export to ZBrush, create an IMM, and it will be really clean. So at the end, the result in ZBrush will look also pretty clean. It will be easy to work with. So stuff like that is, I feel like it's very rare to find a software that will be a full stack, so to speak, like when it will be modeling, retopologizing, rendering, all in the same package. I think that some tools are better for certain tasks and some tools are better for other tasks. And a combination between Fusion and ZBrush is a great combination. Fusion, ZBrush, Keyshot for a concept artist is probably ideal because of the speed and the freedom of what you can do. You can do anything hard surface in Fusion. You can do anything soft or soft body, the regular, what's it called, organic modeling in ZBrush. So it's a great great combo.
So to touch on that, someone asked that, what is the best way to export Fusion work to other programs? it seems like they've had a lot of problems exporting really high density models. So do you have any tips for getting those pieces of geometry out of Fusion and maintaining all of your detail and getting them in a package like Max, ZBrush, Keyshot, whatever?
For Keyshot, the no conversion is required, so Keyshot eats any type of file. So you keep it in CAD, and that's how you preserve all the nerves, the curves, and all that. Basically, you have T-spline body in Fusion, and you have that same T-spline body or solid body in Keyshot.
Okay.
So that is seamless. But for ZBrush, you can control when you're exporting an STL, you can control the level of details that you get out of it. But like I mentioned before, for Max, best way is probably export CAD and use the inside Max tools to convert to poly.
I see.
I also know that some people use Moyo3D to convert to a less dense mesh.
So you'll go from Fusion, bring in the CAD file into Moyo3D, and then export out
an OBJ,
or
a polygon. It will just Moyo3D has a better tool for controlling the amount of polygons that you get.
Okay, cool.
It's just something that I don't use, so I don't really touch upon it in the class. But I do talk about export.
So you go STL file when you bring your stuff into ZBrush, then?
Yeah, that's my usual workflow.
Okay, and that keeps your detail pretty good.
Yeah. If anything, one trick would be, let's say you want to preserve some sort of hard edge, you need to import STL and then do the what's it called, the Dynamesh it at a very high resolution. And a lot of times it will be good enough if you Dynamesh at a very high resolution, especially breaking it down into separate subtools. You will be able to achieve that look, and then use it as a high poly bake.
Awesome.
Shake and bake.
Let's see here. So we have a question that says, why use Fusion 360 over something like Rhino, Alias, I'm guessing like SolidWorks too? I mean, there's obviously like, it's to each his own, but I think one of the best things about Fusion 360 is that it's free and it's super powerful, right?
Right. Well, I mean, it's free for students, and you can extend that license for a long time until you're learning, really.
Yeah.
And then even when you start making really good money, or if you're starting to make like if you're starting a company, a startup, right, and that uses Fusion 360, even at that point, it's still cheaper than any other package. It's like something like $30 or $40 a month, I think, and like $300 a year, something like that.
So it's very cost effective for a professional, and then it's free to learn, unlike I think some of these other programs. So
you can make money back off of your first project.
Yeah.
For the next 5 years of using that program.
Yeah.
So that is one, but then a very obvious answer to that question, why use it over something like Rhino or SolidWorks. Have you seen the interface in Rhino or SolidWorks, where you create like a Boolean or whatever, or a cube, you have to go through console and typing like 50 lines of code?
Yeah.
Rhino. That's something that really is not what I'm looking for as a concept artist. As a concept artist, I'm looking for speed and very intuitive interface. I mean, it doesn't get any more intuitive than just dragging out shapes, and then as I have those shapes, all I need to do to create a complication on that face is just cut it in with another shape. I'm not worried about any edges.
Yeah, like doing that right there would have taken you like 5 minutes inside of Rhino, right? Just to make sure to cut and...
Right, because it's too specific for what I want my software to do.
But you can be specific in here, right? You can enter in all the values by millimeter, right?
Absolutely. Let's say if I wanted to create a bolt inside of this cut, first of all, the Fusion will tell me exactly let's say I want to do it with a sketch. Let me cancel that. When I do it with a sketch, I show to the face. It automatically rotated the face for my convenience, right? No program does that. I haven't seen that. And now it will tell me the center of that shape. It only takes me hovering on top of that edge, and it tells me the center, like where should I place it. It's all parametric, which means that it's all controlled by digits. So when I drag this shape out, instead of guessing the height or whatever, I can just type it in and say, I want it to be 50 millimeters instead of 60. I want it to be 20, and it will be 20.
Yeah.
And more than that, even one of this is something that I touch upon in class. After I'm done with the shape, and this is like a little bolt sitting in there, and I create the cut with it. Even after that, I can go back in history, and I can undo. Let's say I can undo that fillet, or I can change the size, and it will all be I will be able to change the size of that body, right, or of that sketch. So it's very flexible. It does have some limitations where you really think about how to calculate it, how to put it together, not to interfere with the way the program thinks. But that's usually something you do have to learn in any other software. Some very basic guidelines, some very basic rules on how this environment works.
So it's a slightly more linear workflow, right? Would you say in say Fusion versus like ZBrush, where you can kind of just be really random about your process, right?
I would say yes, and I think this is something that I've been striving for as a person with inquisitive mind or like engineering mind. I want more like a more precise way to create shapes. And I want everything to be, you can still do iterations here, no problem. You can iterate your designs. It's just about how you approach that. It's not about the software. So I have several versions, then I will choose one version. I will share the designs in between versions, etc., etc. But the fact that I'm free in terms of, I spend time in Fusion. I spend time on coming up with design rather than spending time coming up with a solution to solve this or that particular shape. And that gives you creative freedom. That gives you an opportunity to think about actually how to make it functional, how to make it look good, beautiful, coherent design with whatever your art director is asking for. Instead of thinking, oh my God, I need to create supporting edges on these polygons to hold up. So that's something that I'm not looking forward to. Like if I ever have to work in polygons again, or not again, but like go back to it sort of, because now I feel like this is an evolutionary step, so where I want every software to be this open, to concepting. Someday.
So we have an anonymous viewer.
Oh my God! No.
We probably have to do this. Anonymous. Okay. They said, "How do you get performance out of your scenes?" He says, "When I have assembled about 200 parts, there's a lot of lag in his Fusion. So, is there any optimization that you have had to do for your larger stuff?"
Yes and no. For example, for the rover, my main optimization was thinking about how I approach modeling, right? And not creating any extra chamfers, not creating any extra complexity in places where I wouldn't see it. And then second step was approaching this as an assembly and keeping everything in separate parts and in separate files. That's for one. But then if you're experiencing more lag, you can always get back into this menu and start changing the visual style and all the effects. So you can turn off the dome. You can see that I have all the effects turned off, so no AO. I can turn the AO, and you can see the difference.
Yeah. So you pretty much like you work in your assemblies because you can work fast in there. It's very similar to any kind of real modeling pipeline where you have to build large cityscapes. You want to work locally on a small complex piece, and then you have your assembly to sort of visualize your big idea.
Absolutely, yeah. I think that's the correct approach anyway.
Yeah.
Especially in hard surface.
So Christoph asked, there's an add-in for Fusion 360 for Keyshot. I think just the Keyshot Pro, you can just import in CAD files, right?
Yes, correct.
Okay.
You don't really need a plugin. It does exist though. There's a plugin, like a one button send it to render to Keyshot.
Okay, like a bridge, yeah. Okay.
Yeah, exactly. It's like a bridge. I think they have it on Keyshot website. Fusion updates often, like every 2 weeks, and sometimes you may not. The bridge doesn't update as often, but I think right now bridge works with every version.
Cool. Let's see here. So Linus asks, he sees more people on Instagram starting with Fusion because big people are starting to use it. Do you think it'll be a big hype soon, or do you think it's already happening? And do you think this program's like really set to take off?
Well, he kind of answered his question because he said that it's starting on Instagram, and when you see stuff like this popping up on Instagram, that means it's catching up, and hopefully, the big guys see it. I mean, the big guys who are controlling the development pipelines and stuff, and they will look at the software and say, this is something that we can actually use. Mm-hmm. And that has been my lifetime journey and goal, to turn a Fusion 360 from something that only engineers can use to something that anyone can use for any purpose. This is a great software for anyone who wants to 3D print at home, and instead of spending time doing your hard surface models in other software like say Max and then prepping it, this makes your model ready pretty much instantly. I want to show this 30-second trick. You take a cylinder, and it will take quite some time to hollow it out in other software, but there's this operator called shell, and it just shells the cylinder, or for that matter, any shape. So I can shell the...
So you can shell complex shapes too instantly.
Absolutely, and I'll prove it right now. I'll join a little square here, and I'll make sure that it's joined. Like, I'll show you it's one single shape. I will blend it together like this. Mm-hmm. So, and actually, let me turn the display on, the one that I'm used to with the edges. Okay. So you can see that this is like some sort of a bottle or a grenade or whatever you want it to be. You can still use shell and point to the face you want to start shelling it from, and you can say, I want it to be a 0.5 millimeter shell, and it hollows it out. Mm. It has certain limitations when it's crazy shapes, too thin of walls, too thin or too thick, or intersecting, stuff like that. But generally, taking your design and making it hollow, and then just creating the necessary support structures, it's really easy. Plus, you can definitely go back, let's say, and say, hey, I didn't want it to be 0.5. I actually want this shell to be 5 millimeters. And it is 5 now. Yeah. You control the thickness. So the point is, it's so easy and so intuitive. You can use it as a concept artist, as an engineer, as a startup. You can use it as just a guy who's starting in 3D. Although there's still more works, unfortunately, for people who know polygon modeling than solid body modeling. But they will change. I want to believe.
Yeah, I think so too. I think there's an obvious benefit to working this way. So a couple questions here. We know this now. So Raf asks, is it he says, I guess it's GPU based, but does it benefit from a Quadra card, or is there no need?
To a certain point. Like we all know, for example, Keyshot is very dependent on the CPU power. Fusion 360 does depend on a graphic card. There's a certain minimal limit that you should have for the graphics card. I'm running this off of a NVIDIA 970, so it's not the top of the line. It's not double Titan or triple Titan like some crazy gamers have. That's completely ridiculous, if you ask me.
So, I mean, you were modeling some pretty complicated stuff on something like a MacBook Air, right?
Yeah, I can do that because Fusion is cloud-based and it's sort of browser-based, so it doesn't really, not to a very big extent, benefit from hardware acceleration. It doesn't really use it right now. I mean, we don't know because with updates every 2 weeks, we might get it by the end of the year if we ask nicely. But because the community actually listens, like I've had a couple of my requests implemented already. Like you can see one of the things that I came up with, you can now see it in this build that we're talking about. It's like a baby. I'm like, oh my god, this is great. The community or the developers listened to me, and I had a chance to contribute to the software. So now I'm even more attached to it. But yeah, I tried opening the rover, and I did one of my previous webinars showing off the rover from a MacBook Air sitting in my car dealership, actually, on their Wi-Fi, and I had no problems whatsoever. MacBook Air is like the weakest machine ever.
Yeah.
You know, it's like
it struggles playing HD YouTube videos, so it's pretty impressive. Yeah.
So I was still able to work with it.
This is a good question here because I know sometimes you might have a STL file that you get from some other source, like you scan something, or maybe you just get an STL from a third party. Is there a way to bring in an STL that's a scan and manipulate it in Fusion, or is it merely a reference?
Yes. Basically, I've tried doing experiments with bringing in polygon bodies from ZBrush even, and some of them were STLs, some of them were straight up OBJs. They come in as a mesh, so it's all polygon.
Okay.
If the polygon is low enough, I don't quite remember the limit. I know it's definitely below 10K. So the lower the better. Absolutely low poly model, you will actually be able to convert it to splines. And from splines, you will be able to convert it to solid body. I had a very good example where this the head and the face and the shoulders. This is a very low poly base mesh from ZBrush, and I was able to clean it up in ZBrush, make it super low poly, bring it in, and it was successfully converted to T-splines, and that's why it's so smooth. So that was T-splines, and then I started creating the solid bodies on top of that face. So this was the end result, where it was like a VR experiment.
Okay, so you can bring in really low-res models and convert them.
Absolutely, it's the living proof that you can.
Yeah, but probably not scan data, I guess. Scan data is typically...
You can bring scan data.
But you can't convert it to a spline, right, to edit it? But...
No, you can... there are some tricks that when you bring in scan data, and they have videos online on their channel, they bring in a bone, which is a scan data, and then they take... what's it called? They take T-spline surfaces, and they wrap around that shape. And it conforms to the scan data, and it wraps around it.
Yeah, it's like a shrink wrapping. Okay.
Shrink wrapping, yeah. Cool. And it actually works. At least in the video they show it worked, and I've tried it myself. It depends. It takes some practice, but it does work. You can bring in skate data. I highly doubt you will bring in like a super high poly face in here, but it depends on what you're trying to achieve. If you scan in, for example, you're trying to build a certain part for your bicycle, you scan that part for the bicycle where it's supposed to go, you bring it in, this will give you a very accurate measurement of how to fit this in. So you don't really need to use that scan data to convert it, but use it as a reference. Yeah. So in that way, it's super useful. I've seen people working on engines, using the pipeline.
So I guess someone asked, is it possible to find a snap to surface function in Fusion 360? Can you show us where that button is by chance, or? Snap
to surface is, if I understand this correctly, Maybe they're talking about something else, but let's see. If I have two bodies and I want if I want this cylinder to snap to the cube, what I have to do is start moving it, preferably in that direction, and then I just point to click to the face that I want to snap it to. It actually, well, it starts with, I need to start moving from the face that I want to snap, and then point it to the face that I want to snap to, and it does snap.
So if that was an imported piece of geometry, that cube there, would it also function in the same way where it would snap to that surface?
No, because it needs to be recognized as a solid body.
Yeah.
You can mimic it. You can match it very closely. You can shrink wrap around it.
Yeah.
Those are some workarounds. But, I mean, because everything is in millimeters here and it's all parametric, you can just actually measure it as accurately as you can and start creating even without the reference.
Yeah, cool. This is kind of a good question I like. Since you're not pushing and pulling vertices and using polygons, do you think it's easier to directly concept in Fusion without reference? And does that go the other way as well? Harder to model from reference since you're not pulling the geo around a 2D concept?
Well, I am the living proof that concept artists can be successfully using it, so I am using it, right? Also, this this lightsaber was modeled using the reference, and the reference was brought in here. I'll show you, because you can just import the reference images here, and when I turn it on, you can see that I used the image of the lightsaber as a reference point for sizing and scaling. So it's definitely useful for anything you want to do.
Yeah.
Whether it is modeling from references or modeling from your imagination.
Do you find it easy to model from your imagination though in Fusion? Like just kind of, you know, like in ZBrush, you just kind of freeform sculpt and move stuff around and kind of find your design through like natural evolution. Do you find it?
That's exactly what I do
in this program too.
And I actually do that in class as well. When I'm modeling the saber, at the stage where I'm starting to add details, I stop referencing so much because I want this to be more of a inventive process, like coming up with details on the go. And because the software kind of forces me to be creative about it, and I find inspiration in everything that I start doing. It's exactly the same process in ZBrush. I find it to be highly useful for coming up with ideas, because as you're modeling in this solid body space, there are some things or some routes of the design that you would not take normally if you wasn't working in it. If that makes sense.
No, totally. That's great. So this is a little above my head, but maybe you understand. Do you sometimes use freeform T-spline modeling in your workflow? If yes, when and why?
Yeah, they're referring to, I'll actually use it in a separate file. They're referring to this mode, which is kind of like the T-spline mode. It's very different because it's very actually close to polygon modeling, where you push and pull your edges and vertices.
Oh, yeah. So it's
and polygons. It's useful for certain things. It's not very useful for others. So if I wanted to create a cylinder, I wouldn't be starting with T-splines. That's a little crazy.
This looks more organic shapes. Like
right. If I want to create, and there's so many people who use Fusion 360 and model cars in here. It's just something that goes over my head because I don't know how to model a car in here. But they come from experience of modeling from T-splines. There are certain pipelines that you have to stick to, and those pipelines I don't really know. I have sort of created my own ways that I work with, but it is here. You can use it, and actually when you're done with the shape, you can stop it, and it will become a solid body. So now, after it is a solid body, you can start creating, using the usual tools on it.
Oh, interesting. So you can sort of just block out some kind of organic shape, like a bike seat or something, like a pillow, like the part of a car that's like
Absolutely.
maybe the seat cushion
Anything.
or something.
Yep. Anything organic
Yeah.
in that hard surface. That's a good example. That if you're modeling a bicycle, a bike seat will be much better done using this tool than just cutting it out of profiles. Although you can do both. I tend to do both.
Hey guys, we're close to running out of time, so I wanted to let's go ahead and do one more question, and then I wanted to let everyone know a little bit more about the class and if they're interested, how to sign up.
Absolutely. Is there any questions about the class in particular that I could answer, or something referring to class?
I don't see anything, but just I could start explaining a little bit how the class works in case people are interested. So basically the way that these classes are structured, they're online classes. Every week we'll have a new video lecture for you guys to watch, and obviously you can watch it at your own convenience. And then every week we have a 1 hour, what we call Q&A, which is a setting very similar to this one, where you have the ability to talk to Kirill, and we encourage everyone to have a webcam, so all the students will have the webcams. It'll be like a live conversation with the teacher if you have questions about the homework, or if you wanted to ask for a demo. It's a very fun and interactive learning experience, and it's obviously it's a big benefit versus like watching this stuff on a YouTube, for example, because you could ask questions about your specific project. Any troubles you're having with, and you have Kirill right there in front of you every week for 10 weeks. This is a 10-week class. And also every single week you have a homework assignment, and we're going to be working on project-based assignments. So, we're hoping that by the end of the term, you're going to have a couple portfolio pieces that you guys have. You could, take them to 3D printing, the concept, whatever it is. And we also get video feedback from Kirill every single week. So you get to turn in your homework, and then you get his critique, his paint overs on top of your homework assignment every single week. So it's basically like a mentorship. It's not, it's obviously has its pros over and cons over like a live physical class. But the great thing that people like about the online classes is that if you have any kind of guesses, or you miss something, you could pause the lesson, rewind, watch it again, and if you still have questions, then you have the opportunity to ask the teacher in the live session. Right now, we're going to be offering anybody that attends the webinar a discount, $50 off the regular price. Let me go ahead and share my screen so you guys could see that. After I'm through here with my pitch, if you guys have any last questions, we'll have Kirill answer those, of course.
Yeah.
So yeah, guys, we this class actually registration ends this Sunday. We still have some seats available, so if you're interested, now's your chance to get in, because it's going to be starting this Sunday, and it's going to be a great time. It's our first time offering a hard surface / CAD type class, and we're really excited because, as I mentioned before, Mold3D started off as a prototyping, 3D printing type of education, and this is like our next natural evolution of what people want to learn, because not everybody wants to do a character. A lot of people don't want to make their own products or use this for concept design as well. So Kirill's a great instructor who's been teaching for a long time. He's been a Fusion 360 evangelist, been working with Autodesk for a while now, and he actually lives this. This is his profession, and he has a lot to teach you guys. So we hope that you guys could join us. Again, webinar discount code WebinarPrint 2016, and you can sign up at www.mold3dacademy.com. That's the end of my pitch. If we want, I think we have a couple minutes here to go over one or two more questions. And thanks again,
maybe
guys.
one.
I just wanted to say that if anybody has any questions after the webinar or before the sign up ends, hit me up on Facebook. It would be my pleasure to talk to you about the class.
Yeah, definitely. I mean, there's so many, everyone has like a different question coming from a different type of modeling background. I've spent years modeling in Maya, so I know where a lot of you guys might be coming from. And then there's also the other side. So I think definitely take Kirill up on that opportunity. Also, if you guys, once this video is done today, we'll be posting this up on our YouTube channel. Just find us at Mold3D on YouTube. You'll find us there, and it'll be the next video that goes out. And feel free to throw your questions up there too. So, yeah, I mean, I think that's pretty much it.
Yeah, thanks guys for joining us today, and we hope to see you online or on Facebook or on
Thank
YouTube.
you very much.
Thank you everyone for attending.
Yeah. Thanks, guys.
Take care.
Bye bye.